When you upload a photo to Facebook, hmm, it instantly recognizes faces and objects. But how does it know? And more importantly, how can we trust that it's correct? Traditional image classifiers like convolutional neural networks are incredibly accurate, but they operate as black boxes. We can't easily tell why they make a decision. That's where explainable AI comes in. It helps open that black box. The book teaches us how to classify the image, but not how to interpret why the model made its decision. Hello, my name is Daniel Hernandez, and today we'll be talking about explainable AI for image classification. Before we hop in, I just want to talk about what we'll be discussing. So I will be discussing what is explainable AI, what's a key technique that's used for it for image classification, and why it matters. What is AI? What is XAI? Explainable AI is about making artificial intelligence more transparent and understandable to us. Instead of simply giving us an answer, helps us see why an AI system made a particular decision. This is especially important because many AI models today work like black boxes. They can make incredibly accurate predictions, but even experts often can't tell how they got there. The lack of clarity can make it hard to trust or validate their decisions. Expl ex Explainable AI addresses this by opening up that black box. It helps us understand the reasoning behind AI's output, which builds trust, promotes fairness, and improves accountability in how these systems are used. In short, explainable AI is about bridging the gap between human understanding and machine intelligence, making AI not just powerful, but also responsible and trustworthy. Now let's talk about one of the most widely used techniques for visual explainability and deep learning, GradCam, which stands for Graded Weighted Class Activation Mapping. This diagram illustrates how GradCam helps us understand what parts of an image goes to the convolutional neural network. Starting in the middle, we have the input image, in this case, a picture containing both a dog and a cat. The CNN processes this image through a multiple convolutional and pooling layers to extract feature maps. These are internal representations that capture different visual patterns like edges, feature textures, or shapes. When the CNN makes a prediction here, identifying the object as a tiger cat, GradCam looks at the gradients following back from the output layer to these feature maps. The gradients show which parts of the image contribute most to the specific class, um, to that specific class prediction, excuse me. Using these gradients, GradCam generates a heat map. The colorful blue to red image at the bottom left. The red areas indicate the regions that most strongly influence the model's decision. For example, the cat's face in this case, um, or in this case, the cat's body, excuse me. The upper part of the diagram shows guided back propagation, which provides fine gradient details of the model's activation. When we combine this with GradCam, we get guided GradCam, a more precise visualization that highlights both where and what the model focused on. So in summary, GradCam helps us see which regions of an image drives the AI prediction. This makes deep learning um, models more interpretable and gives users uh, an, uh, an explanation for what the network sees when it classifies an image. So now that we've seen what an example of how XAI works, let's talk about why it actually matters. As AI becomes more integrated into important areas like healthcare, finance, hiring, and even criminal justice, their decision can have major real-world consequences. If those decisions come from models like black boxes, it's very hard for us to trust or verify them. XAI helps us to solve this problem by making AI systems more transparent, accountable, and trustworthy when we can understand why when an AI made a specific decision. We can understand, we can make sure it's fair, unbiased, and logically sound. XAI also plays a big role in detecting errors and biases. For example, if a medical AI model starts making predictions based on irrelevant background features in an image, explainable tools like GradCam can can reveal that, giving developers a chance to fix that before it actually causes harm. Finally, XAI builds human trust and adoption. When people can see how an AI reached its conclusion, whether it's identifying a tumor in an image or recommending a product, they're much more likely to rely on it and use it responsibly. In short, explainable AI is just about understanding technology. It's about ensuring that AI remains ethical, transparent, and human-centered as it becomes bigger, as a bigger part of our lives. So as we continue to innovate, explainable AI will guide us towards more ethical, interpretable, and human-aligned intelligence, shaping a future where AI not only performs well, but also makes sense. So this concludes my my lecture. So thank you for attending.